are live. Hello, everyone. Welcome to the second episode of my Introduction to Cybersecurity class at Tufts University. I'm Ming Chow. Today, we're going to talk about arguably my favorite topic of them all. Today, we're going to talk about packet analysis using Wireshark. So, one of the things you may be wondering if you've been tuning in, if you're looking at the screen, is well, you don't have any Tufts branding on your stream. Like, what is all this branding that I'm seeing right now? Coincidentally, it has a lot to do with today's topic on packet analysis using Wireshark. You see, I am a member of the Wall of Sheep. I've been a member for a long time. I want to give a shout out to Lead Riverside. Want to give a shout out to all the team members out there. Worked with them for 10 long years and counting. One of the great, real blessings of my life has been working with them. And I even wrote this on Tribe of Hackers, is that the Wall of Sheep team gave me a lot of the cybersecurity education I never got in the classroom when I was a student. And the Wall of Sheep is famous for an infamous display each and every year at the DEF CON security conference. It also runs a packet hacking village at DEF CON. Okay? So, that being said, this was the branding for DEF CON 28, everything that you're seeing on the screen right now, which happened this past summer. And I helped run the Packet Hacking Village talks, which is for, hands-on talks that people can take away something to use immediately after the talk. Well, let me just talk a little bit more about that. So what I'm going to do is I want to give you some background and some overview information first. But most of today is going to be all hands-on demonstrations using Wireshark. This presentation slide, all the examples, I'm just going to go through just preliminaries because it's important to get the basics right to do packet analysis using Wireshark. This presentation, this small slide deck and all the examples are publicly available on GitHub. So that's my contact information, that's my other email address, and that's also the Twitter handle for both the Wall of Sheep and for me. So what is the Wall of Sheep and what is the Packet Hacking Village? So the Wall of Sheep and the Packet Hacking Village, we've been a mainstay at DEF CON for many, many years, and our mission is to work down to security awareness. We do a lot of unconventional techniques and tactics to get the message across. Things like we run peekaboo booth. We run a lot of training exercises and activities. And we do a lot of hands-on workshops. For the last couple of years, our hands-on workshops, all the money that we raise goes to charity, such as the EFF and computer recycling. Our team is all volunteers. But the real mainstay, the most glaring and the most famous part of what we do is this wall. And if you've ever been to DEF CON, you get a lot of advice from people, a lot of infamous advice, and one of them is don't make it to the Wall of Sheep. So what is the Wall of Sheep? Here's actually a picture of a wall from, I think this was from a few years ago. And the Wall of Sheep, what it has is, think of it as almost like a wall of shame of user accounts, their password, first three letters only, domain or IP address, and the application protocol. And so we have access to all of DEF CON's network traffic, arguably the world's most dangerous network. And we monitor the network for anyone who's sending credentials, username and passwords, over the network and securely, unencrypted. And if we find a credential a username and password that is unencrypted in plain text, we will put it on this wall of sheep. This seems like a naming and shaming exercise. It is, but it's also educational. And the point of this education is, don't send username and passwords on, let's say, an insecure website or a software and email protocol that is known to be insecure. Use encryption. So this wall of sheep has been a mainstay for a long time. The whole point of it is for education. Of course, if it's recent now, a lot of traffic now is, encrypted using HTTPS, largely thanks to Edward Snowden. So the wall of sheep, in terms of the activity, as of recent, hasn't been as much as, like, say, a decade ago, where we just found everything. I mean, we were finding Gmail account, Facebook account, Twitter accounts, a lot of high-profile stuff. Remember, 10 years ago, a long time ago, a lot of websites and a lot of services did not use encryption. Now, of course, it's a little bit different, but still, each and every year, we find people sending username and passwords, and sending them unencrypted over the DEF CON network, including people like journalists and even security professionals. Okay? So what is this? How do we do that? Like, how do we do that? How do we actually monitor the network traffic and, of course, ultimately create this thing called the wall? And our techniques are it's not really that special. It's pretty well known, like in the security community. But what we do is we use packet analysis. So what packet analysis in plain English is, we just look at and analyze the network traffic. Okay, it goes by a whole bunch of other names, such as packet tracing, packet sniffing, goes by a whole bunch of names. But what is packet? Well, why? Like, what can you do with packet analysis? Well, what makes it so special? Packet analysis, like any security technique, any technique and tool in security, can be used for both good and bad. Again, any security tool or technique can be used for both good and bad. The goods, for example, like troubleshooting network issue. Oh, you can't connect to the Call of Duty server. You can also record communications such as email, voice, chat. You can actually reconstruct images and other media files if you have a copy of all the network traffic, if you have a copy of all the network packet traffic, and of course, like, catch username, password, and other sensitive information that was sent over a network insecurely, unencrypted. Okay? We're actually going to do those last two things today as part of our hands-on activity. Okay, so this is one of my absolute favorite articles, very recent, and Garrett Graff of Wired wrote this, and I'm happy that he did. And this was in Wired magazine. I want to thank Garrett for writing this article. And there was a little, I guess, miswording in the article about Mirai and the botnet bringing down, and it was kind of weirdly worded, but it was a really good opportunity for us, for us to engage with, like, the non-technical folks. Packets against its target, a little understood forensics process known as analyzing PCAP data. I always joke with people that a student brought this to my attention, and we almost started World War III on Twitter. But it was all good. It was all good. It didn't end up turning into a flame war, but it was a really, really awesome way to engage with journalists and the people who wants to know more. So I want to give a shout out to Garrett for writing this, and I still use this article up to this day. So I'm going to actually teach you how to do this little understood forensics process. But wait a minute, I've used the word packet quite a bit so far. So let's dig a little bit deeper and have a deeper understanding of the terminology. So what is a packet? A packet is just a unit of data. I'll give you a really good example. If you're using Netflix or you're streaming from Twitch, you're actually streaming a movie, you're downloading a web page. Anything that you do on the internet is all made up of a stream of data, made up of a whole stream of packets. Okay? So a single network packet contains the following information: source and destination IP address, MAC address, protocol, time to live, you know, all that information in a packet it contains all that information. But on the technical details, a packet what is called encapsulate all the layers of the Open Systems Interconnection Model, the OSI model. So now, of course, you may be wondering, what is this OSI model thing? The OSI model really is 7 layers. It's 7 layers, and it goes from highest level of abstraction to the lowest level. 7 layers, and what it is each layer is abstracted from each other. So at the very top, layer 7, you have the application layer, which is basically everything that you use and know, things like web, email, chat, file transfer, printer access, directory services. All those applications usually lives on layer 7. And then we have the presentation layer, which is 6, the session layer, which is number 5. The most important ones that we're going to talk about are going to be the transport and the network layer. So the transport layer, what it is, it ensures that messages are delivered error-free in sequence and no loss of duplication. So a transport layer would include things like source port, destination port, the data, the payload. But what is not provided in the transport layer are the source and destination IP addresses. That is actually on the network layer, the one below, layer 3. Layer 3 is the network layer, which controls the operations of the subnet, deciding the physical path the data takes. Well, in short, this is where things like IP address lives, okay? So each and every layer is responsible for something, but you may say, wait a minute, you're telling me that different pieces of the puzzle lives on different layers and they all work with each other? The answer is yes. At the end of the day, they all work together. So the IP address, source and destination, are provided on the network layer by a protocol called the Internet Protocol, IP, Internet Protocol. And then TCP, the transmission control protocol, have things that maintain things like the state, flag, port numbers, you name it. But they work together. And that's why it's called, and I'm sure a lot of you folks, if you ever played around with networking, it's called TCP IP. I repeat, it's called TCP IP. They work together. Then you have the data link, which contains Ethernet. Physical layer, that's where you got cable, hubs, wires, copper, you name it. Okay? So one of the most common questions I get from students is, what's the relationship between IP and TCP? Like, how does it actually look like under the hood? And I'll get to that. I'm going to show you that by way of Wireshark. But there is something called a TCP header. TCP header have a certain number of fields. There's also an IP header. The Internet Protocol has a header that has a number of fields. We're going to see that next. So you know what a PCAP is. A PCAP is, a packet. A packet is just a unit of data. There's something called PCAP file. PCAP stands for packet capture with a file extension .pcap. What this is just going to be a file containing many PCAPs. Just for your reference, like 100 megabyte PCAP file contains tens of thousands of packets. Okay. What is Wireshark? Wireshark is arguably, well, I think it's SecTools, which was written a long time ago. SecTools.org listed Wireshark as the #1 security tool, and there's a very good reason for that. Wireshark is like the quintessential tool, especially if you're working with anything network or network security. If you ever read any literature from on threat intel, threat intelligence, anything on network security, even on application security as well too, you will see mentioning and screenshots of Wireshark. But what Wireshark is a graphical packet analyzer. It's open source. It's free, it's also platform independent, and it has a lot of features that can be used, again, for good and bad. Features such as filtering, reconstructing conversations, and files. So definitely the first thing you got to do is download Wireshark for your platform on wireshark.org. So that's first step number 0 to do today in order to do the activities that we're going to do. So the Wireshark interface looks overwhelming, but it really boils down to 1, 2, 3, 4 pieces. First is the main toolbar. This is where you actually can filter. You can filter packets. You can find packets. You can start recording packets as well too. The second important part is the packet list pane, which is going to be a tabular view of all packets in a PCAP file, or on a live packet capture. So it's a good snapshot of all the important information about packets. The third piece is the packet details pane, which is below the packet list. And this is where the packet details pane, you can see, quote unquote, the layers of the OSI model, and you can actually drill deeper into the different pieces of a packet. And when you actually click or highlight a certain field in the packet details pane, the corresponding raw details will be highlighted in the last piece of the puzzle, which is the last part of the interface called the packet bytes pane, which shows you the binary data. Okay, so okay, this is all nice, but let's do the hands-on demonstration. Let's do the hands-on. Let's do a bunch of hands-on exercises. So this presentation slide and all the exercise PCAPs are available on GitHub at github.com/mchow01/packet, capital P. You can actually clone it onto your computer, git clone, or you can actually just download a zip file of the entire repository on your computer. Unzip that, and then you actually have it. There's a couple of packets, PCAPs, that are well over 30 megabytes for a very good reason. Okay, so what we're going to do now is the very first exercise. The first exercise is open up a simple PCAP file on Wireshark. We're going to start with what is called set number 1 in Wireshark. So I hope a couple of questions just you know, to ask. Now, what we're going to do with the first set 1.pcap. How many packets are there? What network protocol is being used? What's the source and destination IP addresses? What are the port numbers? And also a bonus. Also a bonus. You'll see in a few minutes. Okay. So now I am going to go and type Wireshark. I'm going to open up Wireshark on my Mac. There it is. Oh, you can see it. All right. Good. What we're going to do, first thing, we're going to file. We're going to open, actually, nice, I have my package folder. We're going to open up set1.pcap, 715 bytes. Oh, before I open set1.pcap, just for the fun of it, if you want to really, really look under the hood, let me open up my terminal. Okay, you may be wondering, how does a PCAP file look if you just spit it out on, let's say, a command line or a terminal? Okay, so here are my PCAP files, including the presentation slide. So I'm going to do a cat set1.pcap. In the first lab that I have, which was just familiarizing yourself with the Unix and Linux environment, you know, a lot of students actually say you can use like cat or strings to view the contents of a file on the command line. Ooh. There you have it. Not a lot that you can read with your own eyes. Even if you do strings, Not much. Oh, what? Me worry? If you do file set1.pcap, okay, it will correctly recognize it's a PCAP capture file. But under the hood, a PCAP file, it's all binary, largely binary. I'm going to quit out of my terminal. We're going to come back to this a little bit later. Now I want to open up set1.pcap. Now remember, it didn't look so good under, if I opened this in a command line terminal. Now if I open this up in Wireshark, take a look. There you go. Again, here's your toolbar. Here's my packet list pane. Yes, each and every row is a packet. How many packets are here? Well, first column that you see is called number. And this is just a sequential number. And as you can see, there are 1, 2, 3, 4, 5, 6, 7, 8 packets here in this set. 8 packets. What other observation can you make from the packet preview pane? You can actually see that there are the source and destination IP addresses. You can see the protocol. You can see the length. And you can see a nice little overview of the important information about the packet. You see a number with a right arrow going to another number. And then you see the sync ECN. The second packet has SY, the sync, ACK. And then this third packet has ACK. That may look familiar to you. Yes, indeed. This sync, ACK, and ACK is what you call the TCP three-way handshake to build a connection from the client, from which is a source, to some server at some destination. Okay? You can also see other flags such as FIN. Take a look. But you also notice that each packet that I highlight, the details change. So does the raw packet. So does the raw packet. Interesting. Now, let's click on the third packet here. Okay? Let's click on the third packet. Here in the packet details, you can actually drill down and see the different layers. You can see Ethernet, which is a data link layer. You can see the MAC addresses. Destination MAC address, source MAC address. Type, IPv4, Internet Protocol version 4. The entire Ethernet header. You can see once I highlight Ethernet, come on, right there, you notice that the bytes, it gets highlighted as well too in the raw packet details. Okay? Where is the destination MAC address in the raw packet? First 6 bytes. The source, the next 6 bytes. Of course, the fun ones are Internet Protocol version 4. Let's highlight that. IPv4. This is where you'll find the source and destination. The IPv4, once I highlight this, this is the IP header. All the IP header fields, you can see once I expand Internet Protocol version 4. Scroll down. I can see the protocol. Header checksum. Aha, here's what I want. Source IP address. And you can see on the raw details, the highlight changes. Destination IP address. Source IP address, destination IP address. Okay? But wait a minute, what's the data? What's the port numbers? Where's that? That's maintained in the TCP header. Transmission Control Protocol. expand. Source port, destination port. 1E61 is the hexadecimal value of 7777. Source port, that's used. Destination port, that is used. You can see on the raw packet details, the highlight changes depending on what I highlight. The acknowledgement numbers, aha, flags. Flags are control bits. Okay, flag a control bit to indicate the state of the transmission. But there is an acknowledgement set. A single packet can have multiple flags highlighted. Okay, so for a sync ACK packet, you would imagine that acknowledgement and sync will be marked as 1. Okay, so this will actually give you the packet detail pane here. Where my mouse is, can give you a pretty good drill down of what a packet really contains. Yes, all this information, frame, Ethernet, Internet Protocol version 4, TCP, all that data is in one single packet here. Let's go to the second packet. Let me highlight the second packet here. Okay, and this is a sync ACK packet, a packet containing the sync ACK flags, to be really proper. Let's drill down, transmission control, TCP, because I know that's which flags are actually where flag fields are. Let's go to flags, acknowledgement, set to a 1, sync, set to a 1. So sync ACK, both marked as 1. Okay? So the whole point of set1.pcap is, this is hopefully a not so overwhelming set to begin with, because it's only 8 packets. It gives you to show you some of the real fundamentals of not only using Wireshark, but also understanding packets. Okay. Oh, one thing I forgot to mention. Okay, here, go to the highlight the first packet with the source and destination. And you also notice this number right here, the 49859 with that right arrow pointing to the right, 7777. So what this means, source IP address 192.168.1.3 at port number 49856 to the destination, which is 192.168.1.8, has the port number 7777. You can actually even get the make and model. You can get the make of the hardware that's being used. The source is the source that's being used as an Apple device, and the destination is a Raspberry Pi. Okay, so hopefully this exercise will give you a good introduction on the real basics, the fundamentals of the Wireshark interface, and also how to work with packets as well too. And now you actually see that a packet has an encapsulation of many different layers. In this case, the IP headers and TCP headers as well. Okay. So now we answered all these questions. Let's do a fun example. How do you reconstruct a conversation in Wireshark? Once you actually have a PCAP file, like can you actually rebuild the conversation that happened? Can you actually extract whatever file, the picture, the video that got transferred? And the answer is yes. And so that's what we're going to do now in Wireshark. And let's open up a little more complicated example. Oh. And now I'm going to open up, not set 1, I'm going to open up set2.pcap. This packet set is a little bit more involved. How many packets are there in set2.pcap? Now this is around 30 something megabytes. Scroll all the way down, 38,469 packets. Ooh, that's a lot of packets. So what happened here? something happened. What got transferred? As you can see, if you just keep scrolling, there's only 2 IP addresses in this conversation. The source being 192.168.1.228 at port number 51063. That's the client. The server destination, the server, is 192.168.1.20. And it is running a server at port number 7777. Okay, what's the protocol that's being used to transfer the file? Generally it's TCP, but what does that mean? Interesting. It's not HTTP, because if it was HTTP web, it would say HTTP. It doesn't even say file transfer protocol. It's just regular TCP. Interesting. Now, how does this happen? I'll let you think about how I actually transferred, a file from source to destination. But that's not the point of this set. Well, you may be wondering what happened. What got transferred between the source and destination? How can I rebuild the file or the conversation that happened between the parties? How do I actually reconstruct the the media for what was transferred? I don't know. Well, this is what you do. Highlight a packet, any packet. Let's highlight this one. Highlight any packet. Right click, follow TCP string. So I repeat, highlight any packet, right click, follow TCP string. And watch what happens. The entire conversation is being rebuilt as we speak. Notice right here where my mouse is, the number of packets is growing. But what is this thing? Like, what happened? What is this? You can't see and understand a whole lot here. There's very few things in this conversation that you can even read with your own eyes. Like, you can't see anything here. Like, what? This is all in ASCII text. It's like, what? Maybe the only thing I see a WIDE, I see a 99, I see an MDAT, whatever it is. I don't understand what's going on here. I mean, this is all gibberish to me. What you can do is you can actually save this entire conversation as a file onto your computer for further analysis. So I don't want to save this as ASCII text. I don't want to save it as this way. I want to save it in a format that the computer can understand. And so what I do is this. The entire conversation is 37 megabytes. What I want to do is, instead of saying you're saving it as ASCII text, I want to save it as a format that the computer can understand, and which is going to be what we call raw format. Let's save this as raw format, binary, that a computer can understand. We're going to keep it like let it rebuild until this thing stops. Okay? It's a 37 megabyte file. Like, what could this be? And this is where I'm going to need to use my command line again, and also something that you've learned in the first lab, the Unix lab, the Linux command lab, to help identify what on earth is this thing. So what you want to do is show and save data as raw. Show and save the data as raw, and once the thing stops, do a save as. I'm going to save this onto my desktop. I'm going to save this out to my desktop, and I'm going to call it something. I'm just going to name it as something. I don't know what it is, but I'm going to use the command line to analyze, to help figure out, I'm going to use the command line to say, what on earth is this thing? Save. I'm going to close this. But now on my desktop, I have this file, something. What could it be? I don't know. If I do get info on this, it's 37.7.3 megabyte file. It's a text edit document. I don't know. I don't think that is the case. Let me just open up my command line. Let me open up my terminal and go to my desktop. And we're going to use the file command again. So what's the whole point of the file command? The file command is determine the file type. So now if I do file on something, the answer is interesting. It is an Apple QuickTime movie, a .mov file. Cool. Okay. So what I want to do now, let's do this. What if I just rename this file from something to something.mov? So here's my quick hack. If you want to do a rename of a file, you do a move something and then something.mov. Watch what happens. So I'm going to rename. All I'm going to do is add a file extension, and this also happens to illustrate why having file extension can be really important. Same file. All I want to do is just add a .mov file extension to it at the end. Notice my Mac actually recognizes the file. Really? What happens if I open it now? Gonna file VLC. That was a real movie. That was taken from my phone. That was at last year's. That was last year. I think on day one at DEF CON, and that was at night. No, it wasn't day one. It was the day before the Friday, in which we crashed a party. I'm sorry, Jen Ellis is probably still mad at me. Hello, Jen. But hung out with Josh Abraham, Peter Keenan, and we didn't get kicked out. We stayed after the party, and they had the dueling piano. We hung out for 3+ hours, and it was such a great time. Want to give a shout out to Josh and Peter, which we can hang out. Okay. So we did this exercise, and so now we found out that the media file is a QuickTime movie. Let's do a third exercise. What about pictures? Okay. What about pictures? But also, what happens if you have just more than one file in a PCAP file? Is that possible to actually extract more than one picture or more than one media file in a PCAP? The answer is yes. And we're going to do that here in set 3.pcap. Extracting pictures. And this one gets interesting because it uses I think as a snark, one of everyone's favorite protocol, the file transfer protocol, FTP. FTP, the file transfer protocol, transfers file from a client to a server insecurely. That is, everything's in plain text. There's no encryption. Absolutely none at all. But it's a real fun exercise to work with. So here, set 3.pcap, there's a number of files that are being transferred to an FTP by way of FTP. The source, I have 192.168.1.8. The destination is 192.168, 228, sorry. The destination is 192.168.1.8. So the source port of the client is 49,979, and the destination port of the server, which is 192.168.1.8, is 21. Yes. Port 21 is FTP. Also, the Hacker Jeopardy question that everyone got wrong at DEF CON. Same idea. To reconstruct a conversation, right-click on a packet, follow TCP stream. There you go. Now this should be could show really clear, how insecure FTP is. Everything's in plain text. And you see the username of the FTP server that I use for the FTP server. You see the password? How many files were transferred from the client to the FTP server? Let's count. 1 store, 2 store, 3 store, 4 store, 5 store. But I see 1, 2, 3, 4 JPEG files and 1 text file that were transmitted from the client to the FTP server. Interesting. Can I actually see all the files that got transferred? The answer is absolutely. Here you see stream. You can actually see the different files that got transferred if you click stream number 1. It's the first file that got transferred. Again, this one is a little bit more readable with your own human mind, but it's just still a lot of gibberish. But this is interesting because I see some human readable stuff like profile, I see RGB, I see Photoshop, I see JFIF. It may give you an intuition that this is a picture of some sort. So again, what I'm going to do is I'm going to do a show and save data as. I'm going to save this as raw format. I'm going to call this as output. I'm going to do a save as, and I'm going to actually save this all to my desktop. I'm going to say output. Should have saved that as output 1, but that's okay. And I can actually change it back to ASCII if I want. To see the second file that got sent to the FTP server, here you go. Again, what I'm going to do is raw, save as. I'm going to save this as output 2. Okay, let me see the third stream. I don't want to see raw. What about the ASCII text? Interesting. A text file here got transferred to the FTP server. I can read this. Let me see if I can do this in the voice of Dan Gear. Let me see this. The rate of technological change is certainly a part of it. When younger people ask my advice on what they should do or study to make a career in cybersecurity, I can only advise specialization. Those of us who were in the game early enough and who have managed to retain an overarching generalist knowledge can't be replaced very easily, because while absorbing most new information most of the time may have been possible when we began practice, no person starting from scratch can do that now. Serial specialization is now all that can be done in any practical way. Just looking at the Black Hat program will confirm that being really good at any one of the many topics presented here all but requires shutting out the demands of being good at any others. This entire text, I'm going to save this as output 3. This one's to save it as a text file. This was Dan Gear's keynote speech at Black Hat 2014 in Las Vegas, Nevada. Alright, we got another file. Again, another JFIF. I'm going to save this, I'm going to show and save data as raw. Save as. Output 4. And let's go to a fifth stream. Let's go to a fifth stream. One more. I think that's it. That it? Yep. Show and save data as raw. Save as. Output 5. Okay? So I think I got all my files that got transferred. But how do they look? Can I open them up on my desktop? Take a look. Again, I'm going to open up a terminal. CD desktop. File output. JPEG. Why don't I rename output to output.jpg? Notice my screen. File output 2. Also a JPEG. Rename output 2 to output2.jpg. File output 3.txt. ASCII text file. Full text. File output 4. Okay, looks good. And I would actually have an assumption that output 5 is also a JPEG, and sure enough it is. Just to be safe. And now I can open up my files that I downloaded. Hmm? 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 Not too shabby. So we reconstructed all the files that were transferred from the client to the FTP server in set3.pcap. Okay? So now, what's next? So we've extracted pictures. We'll do one more exercise. But before we do this exercise, I want to give a little tutorial. And this is something that we actually teach at the Wall of Sheep and the Packet Hacking Village each and every summer. It's this thing called Base 64. Base 64 is an encoding scheme. It is not encryption. Base 64 is encoding, not encryption. Base 64 is encoding, not encryption. What Base 64 is, it translates binary data into ASCII text. Why is Base 64 important? Well, sometimes if you output binary data to a terminal, it can cause all kind of weird and interesting behavior. ASCII text, you output that to a terminal, it's a lot safer. Okay? Base 64 is not encryption. But unfortunately, people confuse Base 64 with encryption all the time. Encryption, what is encryption is really hiding secrets. The whole point of encoding is not to hide secrets. Encryption is hiding secrets, let's say, for example, and when you're talking to another party, and let's say you're trying to transfer bank account information. That's encryption, not encoding. Okay? Base 64 is not encryption, but sadly, Base 64 looks like it is used for encryption in what is called basic HTTP authentication. Okay? So, have anyone ever seen one of those pop-up boxes where you actually enter in a username and password? Let me just bring up a web browser. Let me bring up Firefox. Like, what do I mean by those pop-up window with basic authentication window? Something like this. Basic authentication. Google, go to window. Yeah, one of these. You might have seen this authentication required, username and password. That, usually you see a window like this, or this, or this, okay? it uses what is called basic authentication under the hood. The thing is that the username and password is actually not encrypted. It's encoded in base 64. You want to crack the username and password, all you need to do is define this field, this string called authorization : basic. Okay? You want to find that. And the string that is after this field is the encoded version, is the encoding that contains username : password. We're gonna do that now. Well, we'll play Wall of Sheep right now. So we're gonna open up set4.pcap and Wireshark. We're going to find a username and password here in the PCAP set this PCAP set uses basic authentication. And we're also going to see if this username and password belongs into the Wall of Sheep. Okay, let's go to Wireshark. Hey. I don't know why it's not opening up. Got a file open. Let's open up set4.pcap, which is only 17 kilobytes. Really small. Oop. Don't know why that happens. I'm going to clear out the filter. Set4.pcap contains only 170 packets. Really small. But you can actually see HTTP traffic in here. Okay, so remember on the slide we want to actually find this string, authorization : basic. That's what we're looking for. Back to Wireshark. What you can do now is you can do something, use a toolbar called find a packet. You can find a packet by string, if it contains a string or not. So I want to look for packet details, narrow and wide. I want to look for a string. What happens if I do authorization? Can I actually find a packet that has authorization in there? Has a string? Ooh, I got one. Here you go. Wait, which packet was this? Packet number 60 has the word authorization. This is the thing that we're looking for here. Look at that. The packet details say authorization : yep, that's authorization : basic, and then a space. This encoding, this encoded string that starts with a capital Y and ends with two equal signs. This is the encoded string that we're looking for because it contains a username and password. So what you can do is go to right click, you can copy value. Let's do copy value. Now what I want to do is let's open up Firefox again. And I want to do a search for a base 64 decoder. Base 64 decoder. I'm going to click on the first thing that we find. So I'm going to decode a base 64 string. It says type or paste here. This is where you paste this string that you copied from Wireshark. I don't need the basic thing. I just want the capital Y to the double equal sign. And I'm going to hit the code. What's the username and password, please? There you go. It's B. Rogers, : they played with great character. That was when Brendan Rodgers was the Liverpool manager. I'm not going to go hot mic right now, but I could. So the username is B. Rogers. The password is they played with great character. Go back to Wireshark. In fact, Wireshark, when it finds a base 64 encoded string, they actually can decode it for you. I click on it. Actually expand on it and you see credentials. B. Rogers, they played with great character. And any password sniffer, dsniff, ethercap, can find these with ease, relative ease. Okay? Is there another? Is there another username and password here in the set? And the answer is, there certainly is. There's another one. Wait. Oh, no, wrong one. My bad. Yeah, found another one. Credentials, D. Moyes. I am a football genius. Boy, David Moyes was a football genius. God, he was awful at Manchester United. Find authorization. Is there another pair? Is there another credential? There certainly is. This one. Found another one, another username and password pair. A. Ausler. ID10T expert. A. Ausler is a trusty former student. I want to give a shout out to Ann Ausler. She was a fantastic former student. She and I had a great time when we actually kept on bashing Internet of Things, or how insecure they were. Are there any other ones? No. But let's go back for a second. One thing we want to check now is, okay, so we identified username and password. We've identified username and password, but was it legit? Did it get access to the website at all? Well, let's use the technique that we have been using for all these data sets, for all these PCAPs. Right-click. Let's right-click, follow TCP stream. And interesting. So just in context where this was, I found a grading system. This is a few years ago, 2018 it was. I found a grading system that we used at Tufts that was not using HTTPS. It was using HTTP, but it wasn't using HTTPS. So I was just trying to prove my point and entering a bunch of username and passwords, to see if I could capture the password. And sure enough, I did. And sure enough, it would lead to this PCAP set that I always now use for labs. But notice, it's like, even when I followed the conversation, it was like, you can see the result of the conversation was 401, authorization required. Authorization required. This server could not verify that you are authorized to access the document requested. Either you applied the wrong credentials, a bad password, or your browser doesn't understand how to supply the credentials required. Well, this is a no-go. This is not going on the wall of sheep. It's not verified. What about the Brandon Rogers one? Is that any good? This is the Brandon Rogers one, right? Yep. Right-click, follow TCP stream. Still 401. Bad password. Not good. One more. Follow. You can also try HTTP stream. Let's try that and let's see what the difference is. If you actually have HTTP as a protocol, you can follow HTTP stream. It's a lot nicer when you need to rebuild things like JavaScript file, HTML, CSS. Again, this one's no good either because it's authorization required. HTTP status code 401. bad password. So yeah, while we found 3 different username and password credentials, we found 3 of them, but we can't put them on the wall of sheep because um, we're getting 401 errors. They're saying bad password. Now, if it was a 200, or if it said a message something like access granted, we have to look with our eye. Okay, then that's good. Then we put it on the wall of sheep. This is a way to verify username and password without, well, actually breaking into a website, because that's illegal. Anyone ever heard of something called a computer fraud and abuse act? Yeah. This is the safe way to actually see if access was granted, if this was a legitimate username and password, because you don't want to actually illegally gain access to someone, to type in that username and password into someone else's account, like live. Don't do that. Don't do that. So 3 credentials, 3 no goods. No good. Okay? Hello, Bill. Yeah, none of them were valid. None of them were valid. So now, where do you go from here? So where do you go from here? There are a lot of opportunities. There are lots of opportunities with this technique, this skill of packet analysis. Um, you can reconstruct files and even audio and video. If you ever go to DEF CON, volunteer at the Wall of Sheep in the Packet Hacking Village. You can even do our Packet Inspector event. We also have a new event called Packet Detective, where you can hone your packet analysis skills. We have a black badge event at DEF CON called Capture the Packet, some really challenging problems. And one last thing I did not mention here. One thing that's important is, will you see and use this skill again later on for security, for other things such as, for something other than reconstructing files or, catching username and passwords? And the answer is yes. It's common. This technique is common, and packet analysis is commonly used to analyze malware. Okay, malware traffic analysis, if I'm not mistaken, that is the website that has a lot of PCAPs containing malware. Okay, and so that is all that I have for today. For students in my security class at Tufts, you have the full arsenal to complete the second lab, which is packet analysis, which is on packet analysis. In fact, one of these sets, one of the PCAP files, is actually from DEF CON many years ago that you can play and use. And that one is actually identify username and passwords as well too. They may not use basic HTTP authentication. Oh, one note, one question that just popped into my head. You remembered, if you remember something here, when we took a look at this string that is the encoded base64 string containing a username and password, you may be wondering, what is the equal sign? What does that mean in a base64 encoded string? That's important to know. Base64 encoded string, double equal, and I can just tell you off the top of my head, is used for padding. Let's go to Stack Overflow, why does a base64 encoded string have an equal sign at the end? And the answer is, it serves as padding. A more complete answer is that a base64 string doesn't always end with an equal. It will only end with 1 or 2 equals if they are required to pad the string out to the proper length. Okay. There is also another thing that I do want to show, and I want to give out a shout out to Chris Sanders, that the newest version of Wireshark, they'll be coming out soon. Chris, congratulations on your new book on honeypots. Wireshark, the latest version, the next version will have a packet diagram view. So it's great for teaching and learning. So a lot of students have always asked, what's the point of the IP header? What's the point of learning the TCP header? And how does that all relate to packets? Like, where can I see that? Well, now you actually can in Wireshark. So remember the packet detail pane. So now the packet detail pane will also have a corresponding, you can also see where it is on the header as well. Yeah, where you can set to see it on the header as well. Looking forward to this new next release of Wireshark. Okay. So let me take a look. Is there any good questions? Anything? Nothing. A lot of great discussion on Twitch. Yep. So how could you check for a valid peer without attempting to log in? Yeah, we answered that. Right click, follow TCP stream. But weren't these username combinations generated by attempted login? Yep, absolutely. Absolutely. Okay. Yeah, this is cool. This was cool. Excellent. Excellent. What else? Question: how do I find the other username? I only see. Whoa. The question was how to find the other username and password. I only see one GET request with an authorization. Let me go back to that one. So I'm going to clear out the filter. Hit the X here. Clear display filter. I'm gonna hit cancel. So I actually now get, this was set for.pcap. I have all 170 packets here. Magnifying glass, find a packet. I just kept on clicking find a few times. Packet details now wide, string, authorization. Find. Found my first packet that contained the string authorization. Case sensitive too. I hit the find one. Hit the find again. Hit the find again. And I'll just wrap that back to the beginning. Okay, you can also just sort the drop down by HTTP. Yeah, that's another thing that you can do in Wireshark is you can click on a column. You can sort by protocol. Ooh, cool. I see address wells. I see an ARP, DNS, HTTP, and a whole bunch of TCPs as well. Does a color code mean anything? Yeah, that's a good question. Is that the color code, usually I know that when I see green is HTTP, like baby blue is DNS. Okay. Yep. Oh, thank you so much. Yes. By sorting by protocol. I can see a whole bunch of protocols here. Ooh, even TLS, encrypted data, right? I can't ever see this. Can't. All right. So, thank you so much, everyone, for tuning in. So next time it's going to get really interesting. The next topic is we're going to be still on the network, but we're going to be attacking networks the next time. This skill, today we did packet analysis. Next week we're going to do the quintessential skill of reconnaissance. Usually step one of any engagement, and using Nmap. The network mapper. Hello, Fyodor. So we'll do that next week. So we'll find all the goods on probably a perhaps vulnerable system. And then students in my security class actually have to break into a target legally that I give permission to. Thank you, everyone. I'm going to stop the stream. Well, nothing on YouTube. Nothing on YouTube. So I am going to end the stream now.